Question 14. We have a chef school, 60% male, 40% female. 70% of the male and 90% of the females like eating crab legs for dinner. We're going to select a member at random. What's the probability this person is male or likes eating crab legs for dinner? So step 1, draw the tree. So 60% male, 40% female. 70% of the males like eating crab legs, so it's a 0.7 there, 0.3 there. 90% of the females like eating crab legs. Because of the conditional part, it says 70% of the males like crab legs. That's why I know the crab legs part and like and dislike are at the second tier of the tree. Now this problem asks us, is male or likes eating crab legs for dinner? Well, we can do this with our union formula. So from our tree, probability of male is 0.6. Likes crab legs is every branch that ends in an L. Minus male and crab legs, that's this branch. Now, that's one way of doing this. We could have also looked at this tree and said, okay, male. All the branches that the male is involved in is those two. Likes crab legs. All the ones that involve liking crab legs are those two branches. Looking at this, well, what do we do with our answer? Well, union means take them together, so we take all the branches that we have marked. So it's 0.6 times 0.7 plus 0.6 times 0.3 plus 0.4 times 0.9. Now, part B says, what is the probability the person selected is female, given that the member likes eating crab legs for dinner? So we know L, we're asking the probability of F. Well, that's backwards on our tree, so we use our formula. So female and likes crab legs, it's this one branch right here. And then divide by the probability of liking crab legs, it's all the branches that end in L. Question 15. Doug takes a history quiz and guesses on every question. Forgot to study. The quiz has 5 questions and each question has 4 possible answers. What's the probability he will get at least 3 of the 5 answers correct? So we're at least 3. That means 3, 4, or 5 correct. Well, let's just do 3 correct. Well, combination, 5 choose 3, because we had 5 questions total. So 5 choose 3 will give me my 3 questions to be correct. Now, there's only one answer that's correct, so each one of those questions you have one choice. The 2 questions that you miss are going to have 3 choices, because we had a total of 4 possible answers. So the 1 to the 3rd is each question that was right had 1 choice. The 3 squared is those 2 questions that were wrong had 2 choices, had 3 choices each. So this gives me all the ways of getting 3 questions correct. Now we do 4 questions. Now really 1 to the 4th isn't needed. I'll just put it there to keep the form. And then all 5 questions correct is just one way. Now we want it probability, so we need to divide by this. Well, how many different ways are there to answer these 5 questions? 4 to the 5th. Think about each blank's going to have 4 choices in it. Now, when we get to section 8.4, this is easy. In this case, in 8.4, n is 4, r is equal to 3, 4, and 5, and p is equal to 1/4. So we'll explain what those mean when we get to section 8.4. Okay, at TU, 35% of the freshmen failed math, 20% failed English, 10% failed both. So here's math and English. We know 10% have failed both, so it's 0.1 there. 20% had failed English, so it puts a 0.1 there also, because the whole thing has to add up to 20%. 35% failed math. There's 35%. And 25, 35, 45 makes this 0.55. We know it's a Venn diagram because it talked about this percentage, and then percentage that did both. Now, part A says, what's the probability a freshman failed exactly one of these courses? That means only math, which is 0.25, or only English, which is 0.1, gives us a 0.35. If a freshman fails math, what is the probability they failed English? So we know they failed math, that's the given. And we want to know what's the probability they failed English. Well, convert this over to regular probability. English intersect math, that's 0.1. Probability of failing math is 0.35, and you can compute that out on the calculator. Question 17. 2 marbles are drawn in succession without replacement from a box containing 5 blue and 3 green marbles. What is the probability the second marble is blue given the first marble is green? So what do we know? We know we have 5 blue and 3 green. Well, this right here told us the first one was green, now we're down to 2 green. What's the probability the second marble is blue? Well, there's still 5 blue, and there's 7 that are left. Question 18. 60% of toasters in a warehouse come from the hot slice company, and of those toasters, 3% are defective. 40% come from this other company, and those 5% are defective. What percentage of the toasters in the warehouse are defective? Well, this stage, draw our tree, hot slice and the other company. We have defective and not defective. So 60% of those from that company, 40% from there. 3% of the hot slice toasters are defective, and 5% of the other companies are defective. Now, we don't need the 97% and the 95%. I'll throw them in the tree. And the question is, what is the probability, or what percentage of the toasters in the warehouse are defective? So it's all the branches that end in D. So 0.6, 0.03 plus 0.4 times 0.05, and we compute this out, and we get 0.038. So the answer is 3.8%. Question 19. 20 people are asked to write down an integer between 1 and 50 inclusive. What is the probability that everybody wrote down a different number? Well, we could draw out 50 blanks. The first person would have 50 choices, the next person would have 49, 48, 47. Write out 20 blanks. So 50, 49, 48, 47, 46. But if you think about it, we're not allowing repetition. Order is important because, in essence, each person has picked their own number. If Bob picks 3 and Sue picks 15, that's different than if they swap numbers. So we have a permutation. We had 50 numbers to pick from, and we want 20 of them. That's the same thing as writing out 20 blanks and start off 50, 49, 48, 47, 46. Now we need to divide by something. Well, how many ways can anybody pick a number? Well, each person has 50 choices, and there's 20 people, so 50 to the 20th. That's the shortcut. Now, part B. At least 2 people wrote down the same number. This problem is difficult because you say at least 2 people wrote down the same number. You could have pairs of 2s, or 3 of these 3 people, these 4 people, those 5 people. In other words, that makes this hard. So really the best way to work this problem is 1 minus the probability that they're all different. So 1 minus the permutation 50 choose 20 over 50 to the 20th power. Question 20. 50 people are asked to write down an integer between 1 and 40 inclusive. Find the probability that at least 2 people write down the same number. Well, this one is actually very easy. The answer is 1. Now, why do I know that? Well, the key is we have 50 people. And we only have 40 numbers. So if you assumed everybody wrote a different number down, after 40 people, everybody has a different number. Now, the next 10 people still have to write a number down. Whatever number they choose is going to repeat one of the previous 40 persons. So notice here, we only had 40 numbers to pick from, but we had more people. The difference between this problem and the previous problem we had 50 numbers, but we only had 20 people. That's why we had to do a little more thought. So in this case, we're guaranteed to have 2 people or more than 2 people write the same number down just because of the number of people and the number of choices they have to choose from.